Kia ora, my name is Hokapuni, and today I am joined by our Associate Engineers here at Indigenous Consulting. Our team has been tasked with presenting construction methodologies for oil and gas facilities. Collectively, we decided that the Marsden oil refinery would make a great case study, seeing as it is New Zealand's only oil refinery. Firstly, I'll give a brief introduction or overview of the Marsden oil refinery. Secondly, our team will explain the construction methodologies for site preparation, secant board piling, and the capping beam. And lastly, key points will be summarised for you to take away. It is important to note that the construction methodologies outlined in this presentation are based on personal experience, input from industry practitioners and online resources. So without further ado, let's get started. The Marsden oil refinery is based in Whangarei and is New Zealand's only oil refinery. It is the leading supplier of refined petroleum products with a particular focus on refining crude oil into high quality transport fuels such as petrol, diesel and aviation fuel. I will now hand over to Sunny, who will provide an overview of what's involved in preparing a site for construction.
Thank you, Ho. The first part of construction methodology was site preparation. The first step of site preparation was site layout planning. This process considers safety, accessibility and information science as a means to ensure the efficiency of managing material, equipment and people around the site. Multiple site plans were expected throughout the different construction phases. This was due to either space and access requirement variations or the addition and removal of plant around the site. When setting up the site, the first priority was to establish welfare facilities for the staff. Providing adequate on-site welfare facilities acknowledged the team and also increased productivity. Upon establishment of these welfare facilities came plant and equipment delivery. This included rollers, excavators and other relevant gear. The construction area was then cleared of all trees and debris. It is important to note that permits were required for certain trees where breaching the permit conditions could have resulted in project delays, fines and even prosecution. Depending on the scale, debris removal was achieved through other machinery or through manual labour. Once the site was cleared of all debris, trucks delivered aggregate to form a level working platform. The aggregate was deposited by trucks, spreaded by graders and compacted by roller machinery. Compacting the aggregate prevented any future settlement of the working platform. Lastly, haul roads were installed for heavy load deliveries around the site. The haul roads' desired location, depth, thickness and layer configuration were respectively decided, excavated, graded before the final surface layout was placed. I will now hand over to Lucan, who will provide an overview of piling.
Thank you, Sunny. As part of the $365 million Te Mahiho project, a new CCR platformer was introduced to replace the existing unit. The CCR platformer is fixed on a concrete base that requires a suitable foundation strata. To enable this, secant board piling was used to assist soil excavation by preventing the collapse of the surrounding soil in order to reach this foundation strata, where a base could be constructed for the erection of the CCR platforms. CCR platforming is a catalytic reforming process for upgrading naphtha feedstocks into high-octane gasoline blending components or into the petrochemical feedstocks used to produce plastic resins, films and fibres. Secant board piling consists of the formation of overlapping concrete piles. Unreinforced or female/soft piles utilize lower strength concrete, while reinforced male/hard piles form a steel concrete composite structure. Firstly, a shallow guide wall is constructed to locate the piles accurately. Without a guide wall, the holes drilled may deviate from their desired path, forming voids in the wall. Polystyrene formers are placed in the excavated trenches and concrete poured around them to form a wall. Formwork will need to be set up so that the concrete can set in a certain shape and not just flow everywhere. Prior to any concrete pours, tests like the slump test will be completed to ensure concrete quality is adequate. Once the guide wall is set, the piling rig can begin to drive a hollow steel casing into the ground while still having the top protruding to allow for removal later on. Augering will then begin, which is when the piling rig drills down to the desired depths and removes soil from the ground to form boreholes. Once all the soil is removed, concrete can be poured. If the current pile is a hard pile, then the steel reinforcing cages will be placed inside prior to the concrete pour. The concrete pour will use a tremie pipe, which is an attachment which allows for the concrete to be poured from a height without causing segregation or damaging the steel caging. A dogman will be present to guide the movement of the tremie pipe into a borehole. I will now pass on to Teringa to talk about the capping beam.
Thank you, Luca. Kia ora. My name is Teringa, and today I'll be talking about capping beams. So what are capping beams? As Luca just explained, piles are put into the ground in order to reinforce the soil. But as construction continues, the forces acting on those piles are going to increase, and without proper reinforcement, those piles will break. This is where capping beams come in. They are strong structures that hold the piles together. So, how are they made? In terms of our project, the first thing that we did was establish a blinding. This gave our team a level platform to work on. After that was established, using various tools, the concrete around the piles above the ground were removed in order to expose the rebar. Then, prefabricated rebar frames arrived to the site and were put on top of those rebars. Formwork was installed to act as a mold for the concrete. Then, our concrete trucks came to the site and we began pouring concrete. After the concrete was poured and allowed to cure, the formwork was able to be removed. Then, that left us with this, a beautiful capping beam that, 1, holds the piles together, 2, provides a safer working environment for our team to work in and around, and 3, prevents the failure of the excavation. I will now hand it over to Matariki to summarise.
Thank you, Teringa. To bring things to a close, this presentation has highlighted some of the fundamental aspects of construction methodology. In theory, we have touched on key components related to site preparation, piling and capping beams, and have described these in the context of Marsden Oil Refinery. Once again, it is important to note that the construction methodologies of this presentation are based on personal experience, input from industry practitioners, and online resources. In summary, the construction methodology of site preparation is paramount for engineers to understand and to achieve on-site health and safety, welfare facilities for all on-site personnel, and ensuring awareness and isolation measures for public safety. Concerning piling and capping beams, guaranteeing clearance of all site debris, proper handling and storage of materials, and adequate equipment and plant must be prioritised. It is important to note that certain jobs beyond the scope of the works of the project may require permits or resource consents. These often occur during site preparation and will usually result in additional cost and delays, but it is still essential to note to avoid fines and prosecution. We are Indigenous consulting, solving problems and providing engineering expertise is what we do. Thank you.